Assalamualaikum. Today's topic is ordered statistics. Ordered statistics is actually the arrangement of the random variables in order to their increasing magnitude. Here we have the definition of ordered statistics. Let x1, x2 up to some xn be a random sample of size n with some certain CDF with us. Then the y1 less than and equals to y2 up to so on less than and equals to yn is the arrangement of the random variable xi is in order of increasing magnitude. This arrangement is known as ordered statistics corresponding to xi's variables. Now for variables, we will find out the distribution of those ordered statistics variables if we have given the information of the actual variables, actual random sample with us. So if we need to find out the distribution of rth order statistics, which may be written in this form, we may write it in the form of yi's, or we may write it in this notation. We may use any of the notation with us. Then if we want to find out the distribution of any of the ordered random variables, so that is given over here in this equation with us. R may take any of the value. It may be the smallest number, that is 1. It may be the largest number, that is n, and it may be any value between 1 to n, from 1 to n. We will take the values, and by putting all the information over here, we may solve it and then get the information. Now if we put r is equals to 1, it will give us the density of the smallest ordered random variable, which is of this form, and then simplifying it, we get this sort of result with us. Similarly, when we take r is equals to n in the given formula of rth density, then we are actually finding over here the density of the largest sample observation in ordered statistics, and its formula on simplifying it will give us this information. Now as example, let's suppose we have 5 observations with us with the density function as e raised to power minus x, and we are in need to find the distribution of the median, distribution of the smallest number, or the distribution of the largest observation. So for that, we will use the formulas as we have seen earlier. Since n is equals to 5, then the median will be third observation, so r is equals to 3. For smallest, it is r is equals to 1, and for largest, it is r is equals to n. Then if we take we are taking n is equals to 5 and r is equals to 3, f of x is given to us. We may able to find out the capital F of x by using its formula. By simplifying it, we have this information with us. Now putting the value of capital F of x, small f of x, n and r into the formula and simplifying it, the resulting term is the density of the rth observation, or you may say that this is the density of the median of observation in ordered statistics. Similarly, by putting r is equals to 1 or in the above formula, or in the formula as we have done earlier, we taking the density of f of x1 and f of xn, we may able to find out the densities of the smallest observation and largest observation of ordered statistics. Next is the joint distribution of rth and sth order statistics, meaning if we have rth some observation with some variable with us and sth variable with us, then the densities of these r and s, joint density in order statistics, may be find out by using this particular formula which is given over here. For this purpose, we have a next example with us. We have 4 observation and the densities of those x1, x2 up to x3, x4. We have the densities as this one, and we need to find out the joint density of second and fourth observation. So as we have done in the earlier formula, we need small f of x, we need capital F of x. So capital F of x again maybe find out by integrating it from 0 to x and solving it, we get this one. Now by putting the value of n, r, s into the formula which we have done earlier, and then simplifying it, solving it, this ones may be cancelled out, this one may be cancelled out, and then we will get the particular values. By simplifying it, the resulting term will be the joint density of second and fourth observation in ordered statistics. Now up till now we have done the densities of the rth observation and then the joint density of rth and sth observation. Similarly, next we have the distribution of the range in ordered statistics. As we know that range is the difference between the largest and the smallest observation. So we need to find out the density of this. This question is sort of transformation, as you see that we have given some new variable, that is xn minus x1. So then we may solve it by the method of transformation. So for that, what we have the joint density as in this form with us. When we have given joint density in this form, we will put over here the value of r and s, and then solving it, it will give us this one. Now since we have a variable xn minus x1, let's suppose we take x1 as is equals to w, so then xn will become this one, and then Jacobian of transformation may be computed, which will become 1. Now putting these values of r and w and similarly the Jacobian transformation into the observation, we will find the joint density of r and w with us, which is this one. Now we are in requirement of finding just the density of r, not with w. So we will calculate as its marginal density over the value of w. When we solve it, since its solution is not easy task, so we will have this particular formula with us, and by using this formula in any of the situation, we are able to find out the density of the range in ordered statistics. For this purpose, we have an example, and in example we have given a density that f of x, small f of x, is 1 over beta raised to power minus x over beta, and we are in need to find the distribution of range. What we will do, we know the formula given over here is this one, and in this we are in need to find out the CDF of x1 plus r, CDF of x1, PDF of x1, PDF of x1 plus r. So f of x is given to us, capital F of x, maybe find out, you know how to find the CDF of any density function, which is given over here. Now what will happen if we need the capital CDF and small CDF, capital F and small f of x1? So what we will do, we will replace the x's with x1s in the formulas, and similarly for x1 plus r, for finding the densities and CDFs, we will interchange it with x1 plus r and x1 plus r. By putting these values over here and then simplifying it, thus as this will become the distribution of range in ordered statistics. That's all. Thank you.